Let's talk about some more applications of systems of equations. This example is going to be another super common one in algebra, and that is where we are mixing candy. So in this situation, our goal is to make a total of 15 pounds of candy, and we're going to combine two different types of candy. So I see that he wants to make a total of 15 pounds, and it's going to sell for a price of $4.25 per pound. The first candy that he's going to pour into the mixture is this one that costs $5.50 per pound, and the second one is $3 per pound. How many pounds of each should he use? Well, we've got two different things we're talking about. We're talking about price and we're talking about the weight. So let me first write an equation that just talks about how much of each candy we're going to use, strictly based on the weight. So I will let maybe X be my $5.50 candy, and Y, I will let that be my $3 candy. So I know that if I'm using X pounds of the $5 candy and Y pounds of the $3 candy, if I add those weights together, X plus Y, I'm going to get the total amount of weight that we want to end up with, which is the 15 pounds. So you pour a bunch of one candy in, you pour a bunch of the other candy in, together those weights make 15 pounds. That's the equation we just wrote here. Now, the second equation we're going to talk about is based on the price. So the second equation is going to look like this. I'm going to talk about the amount of candy that I have, and I'm going to multiply it by the price. So it's $5.50 per pound, and X is the pounds. So if I have 1 pound, I just have $5.50. If I have 3 pounds, I have that $5.50 3 times. So I'm just going to multiply it by the weight of my candy. So that's what I did here. This tells you how much that you're going to contribute from that $5.50 candy. Then I'm going to add on the price of my $3 candy. So I have $3 per pound, so $3 multiplied by the number of pounds that I'm using. And that gives me the total for that $3 candy. Now, all together, I want this mixture to cost $4.25, and the amount that we're using is the 15 pounds. So it's price times amount plus price times amount equals your final price times amount. And now this is a system of equations that we can solve. You could solve it using substitution or elimination. Either way works. I think my preference will be elimination. So first thing I'll do is I'll go ahead and multiply this 4.25 by 15, and I get 63.75. So let me rewrite that. And then looking at these, if I want something to cancel, I think the easiest thing is going to be to multiply by a -3 here on the Y, and that way I have the opposite of the +3 down below. But of course, I can't just multiply the Y. I have to multiply everything on the left by -3 and everything on the right by -3. So I will write the new equation below. I've got -3x minus 3y equals -45. And then I add. 550 minus 3 is going to be 250x. My y's cancel. And 63.75 minus 45 is going to be 18.75. So now I've got an equation with only x. I can go ahead and divide both sides by 250 to isolate the x. And x is going to be 7.5. So that tells me that I need 7.5 pounds of the X candy, which, if I go back up to the top here, was that $5.50 candy. So I need 7.5 pounds of the $5.50 candy. Well, we know that we need a total of 15 pounds because X plus Y equals 15. So let me throw that 7.5 in for X, and I can solve for Y. And we find that y is also 7.5. So I know that I need 7.5 pounds of both of the candies that I'm using in order to reach my goal. So I need 7.5 pounds of each candy. And that would be one possible way to solve this mixture question. Thanks so much for watching, and I'll see you next time. Bye.